So, hello and welcome to another video of the Talking About Testing channel. I am Valmir, and today I have the pleasure of receiving John Ousterhout here at the channel. Hey, John, how are you doing today?
Hi, it's great to be here. I'm looking forward to our conversation.
I'm looking forward to it as well. So, today I have the pleasure of receiving John Ousterhout. John is the author of a book I pretty much loved when I read, which is A Philosophy of Software Design. John is also a professor at Stanford University. John has a BS in physics from Yale University and a PhD in computer science from Carnegie Mellon University. He was a professor of computer science at the University of California, Berkeley, and he also worked as a distinguished engineer at Sun Microsystem Laboratories. He founded Scriptix Corporation to commercialize TICO development tools. He worked at Electric Cloud, and in 2008, he returned to academia in the computer science department of Stanford, where he taught web applications, operating systems principles, and also software design. John, I am so pleased to have you here. First of all, I want to mention that at the moment of this recording, the Talking About Testing already have four videos dedicated to sharing a bit of John's wisdom. And all these videos can be found at the book club playlist, where I talked about his book and also about an article he wrote in 1998 called Scripting Higher Level Programming from the 21st Century. I found it so impressive because you wrote that so long ago, and we see what you wrote in there happening nowadays. So it seems that you predicted very well what was going to happen. John, I brought you here to get your insights about test design. And when I say test design, I mean software design, but applied to testing. And I mentioned to you in your book's Google group that I have started last year a mentorship called Test Design Masterclass, where I teach my students about software design applied to software testing. And the Test Design Masterclass methodology was really inspired by your methodology at the CS 190 Software Design Studio course. And I can tell you that I found lots of connections to the things you share in your book, A Philosophy of Software Design. So I have listed a few things here that I wanted to discuss with you. And before we start talking about it, one thing that I wanted to mention is I love the art from your book because on top we see like a spaghetti code, and then we apply a philosophy of software design, and we have like very well decoupled software. Who made this art?
Um, it was a group of people we had been using for website design, and we really liked the website designs they did. And
Yeah.
so I asked them if they'd like to try designing the book cover, and we noodled it together over that cover for a couple of months.
Mhm.
Actually, I'm thrilled that you actually got what the cover
Yeah.
was trying to do. I sometimes worry that maybe it was too subtle and nobody would really understand what the cover was trying to say about software design turning spaghetti code into something more reasonable. So that was very fun to see. You're the first person who's actually mentioned that they
Oh,
got the idea of
to
the
me,
cover.
I look at it and this is what I see. It's like spaghetti code on top, and then the philosophy, and then very well designed code at the bottom. John, so I have a list of things here that I want to discuss with you. So in my mentorship, what I do is I created a web application that has a front end, it has a back end. The front end is very well decoupled, so you can build the web application using components, and you can test the components in isolation and that kind of thing. And then I give to my students the exercise of testing the application differently than what you do at the software design studio, where they have to build an application. I have already built the app, but they have to test it. So they test the app in many different levels. So they test the API for the backend part. They test the front end. They have to test the components in isolation. They have to test things related to accessibility and that kind of thing. I also teach them what I call the elements of test design, which are 14 elements, 14 things that I think are very important when we are talking about testing, automated testing specifically. And and after that, they have a week to do the exercise. So they have to fork the project from GitHub. They have to run the application locally on their computers. And depending on their level of expertise, they have different exercises that they have to do. And then after they do this, like they have actually 5 days to do it, and then they create a pull request for me to review. And then I start reviewing it and I give them feedback so they can improve. And some of the things that I see when I am reviewing it for the first time are tests that are hard to understand. And they are hard to understand sometimes because they are not too descriptive. They use sometimes too much abstractions. And I don't think this is a thing just with testers. I think developers usually they abstract sometimes too much, at least in the beginning. I don't know what's your impression on that. They hide important information about what the test is doing. So, for example, I don't like abstracting the assertions of a test away. I want to look at the test code and see what are the assertions. What is this testing really, right? Um, Sometimes their tests lie. They describe the test as doing something, but when you read the implementation, it's actually doing something else, or it's doing a little bit more than what it's describing, or it's doing less than what it's describing. Um, so I wanted to hear your thoughts, firstly on that topic, like tests that are hard to understand.
So this is an interesting conversation to have because I write a lot of unit tests. I'm a huge
Mhm.
fan of testing, and in particular, unit testing. Don't talk about
Yeah.
it in the software design book because it's a book about design more than about testing.
Yeah,
I
there
want
is
it
a
to be
little
a
bit about
book
it
and
on the one
only a
of the
little bit.
last chapters, right?
So now it's possible that maybe I'm actually maybe the tests I write aren't great. I sometimes wonder about that, but I find that the at least once I get the framework set up right, I find unit tests relatively easy and straightforward to write.
Hmm.
Um, not always easy to read when I come back to them. I have noticed
Hmm.
that because oftentimes in a unit test you have to spend a fair amount of time setting up the right environment, preparing things in order to actually run the test, and that can be a little bit complicated. So, I've occasionally wondered, is there some way of doing tests that I'm not thinking about that would make this easier? But I,
Hmm.
I I have to admit, I haven't spent a lot of time thinking about that. I've mostly just kind of pushed through it to get my tests running and to update them as I make changes to the code.
Yeah. In my case, like in the case of the test design masterclass where I teach my students, they don't have to write any kind of unit tests. They test like they write integration tests for an API that I wrote in
Right.
Node.js. So they have to test like REST API. So they have to make requests, passing different query strings, and see if the JSON that is returning has the correct schema and the correct attributes and that kind of thing. And in terms of the front end, they have to test. Then it can be a kind of unit test, but for something that you can visually see because it's like a decoupled component, so it can be just a button or part of the front end application, like a table with some information that you don't need to connect the database to. Like if you were testing just a component, you can feed it with some data to see how the table would render and that kind of thing. Um, there's another thing that I see a lot, specifically when we are talking about testing front end applications. So, and I know this is not like your area of expertise, so I will try to give you examples to see if I can make you visualize that kind of thing. So, Besides unit testing, in the world of software development, there's also what is called end-to-end testing, right? Which is testing the application from the end user's perspective. So you have, for example, a web application, you have to open the browser, visit the web page, fill a form, submit, and see what happens, right? And in that sense, there are some patterns that the development and testing community invented to make it simpler, to make it easier to deal with that kind of thing. And this is especially because in the past, there were no great tools for doing that kind of testing. So in the past, there was Selenium and other kind of creepy tools that were very hard to set up, very hard to understand when you read the code. And then people invented something that is called page object model, where you abstract away in a class, for instance, the elements of a web page and and methods that can interact with the elements of that web page. And then inside the test, you import that an instance of that class, which has a good name, and then you can assert that, for example, certain message is visible. You can interact with the elements of that page to fill a form, click buttons, that kind of thing. But nowadays, there are tools that advanced a lot, and they have very good abstractions for things that these older tools didn't have. Okay.
If I could, if
Yeah,
I could
for sure.
interject, I actually have a little bit of experience testing web applications, although
Hmm.
it's a long time ago, and in an
Hmm.
environment that was pretty tools poor. And so maybe today's environments, maybe the tools you're talking about are rich enough to help make it easier. But
Yeah,
what I found that testing the back end of web applications was fairly straightforward. I could use relatively standard unit testing approaches.
I agree with that.
Testing the front end, I found extremely tedious,
Hmm.
very difficult both to create the right infrastructure sort of for generating the right conditions for tests, but then also because so much of the output is appearance on the screen,
Hmm.
trying to evaluate whether the appearance is right
Yeah.
and doing it in a way that so in many cases I would simply just test the HTML that was generated,
Hmm.
but then that's extremely sensitive to any small change you make, which may not really change the output in a meaningful way,
Hmm.
but actually breaks the tests. And so the tests ended up being very fragile.
Yeah.
And this was so challenging that I began to wonder if maybe it wasn't even worth trying to unit test the front end
Mm.
stuff because it was so difficult. But hopefully maybe there are better tools that can make this easier today. Is that your view of the world now?
Yeah, I can tell you that today, at least one of the tools that I use nowadays, it have advanced a lot in that sense. Nowadays, I use a tool called Cypress. So it's even the name Cypress is because Cypress is an evergreen tree. So it's a tool that allow you to write tests that are going to be evergreen if the application is behaving as it should. And actually, this tool specifically, it like the team that developed the tool, they are not testers. They are very great developers. And because of that, they thought, you know what? We have to write something completely different than what we had before because we didn't like to write tests because it was terrible experience. The tests were flaky, non-deterministic, that kind of thing. You change something in the app and then the tests break, but the app is actually working. And they actually have thought about every abstraction to make it very easy and for you to write tests in a very fluent way. They even thought very well about different defaults for like the size of the screen that is going to render, default timeouts for different stuff. So for a page load, the default timeout is like 60,000 milliseconds, but for a element to appear in the screen, it's just 4 seconds. For a request to happen, it's something around 30 seconds, because they know that applications, they are not like we want them to be in real time rendering things for us, but we know that that's not the case every time. We have servers and latency and that kind of thing. Um, so one thing that I see a lot when I'm reviewing the exercises of my students, and they have to use this tool, which is very well thought, and still some of them, they create abstractions for things that would be needed if they were using an older tool. But using this tool, the abstractions are already very well thought. So I will give you two examples of abstractions that exist in this framework. One of them is to visit a web page. You have, so inside the test, you have a global object called Cy, which is like a short name for Cypress. And you can call from this object sci.visit, and you pass the page you want to visit. So I want to visit the login page, for instance. So I write sci.visit parentheses, and inside the parentheses as a string, I pass /login, and then I visit the login page. And people sometimes, they create an abstraction called visit the login page, which only runs this one command, which in your book you call this a shallow method or a shallow module, right? So I want to hear your thoughts on that, because sometimes what I tell them is like I have to write more lines of code to implement the method and call the method in the test than just implementing the, like just adding the site.visit in line in the code, for instance.
I'm wondering if maybe the problem was that people weren't familiar with all of the facilities provided by the tools.
Mm-hmm.
And so they decided it would be faster just to roll their own special purpose stuff than to try and figure out a more general purpose tool that they could use that was already available.
Yeah, the impression I have is that they had experience with these old tools, and they bring these
Mm-hmm.
old behaviors from tools that had not very great abstractions, and they bring it together. And this is something that I actually wanted to hear from you, because sometimes we have to change our minds. We have to understand that there are new technologies coming up, and we have to forget some things the way we used to do things, because there are better ways to do it now. But people, they sometimes they don't want to forget. They don't want to, they think, no, I spent so much time learning that, and then I can't use it anymore. But it's actually for their own good and for the good of their teams and that kind of thing.
Yeah, it's, I think everyone working in an environment like this, I'm sure this is the way I feel. You're constantly asking yourself the question, what's the easiest way to get this job done that I have to do?
Mm-hmm.
And if I know a way, even though it, may require a little bit of coding and creating a little mini new special purpose abstraction, but if I know that will get the job done, it's kind of tempting to do that rather than to say, well, is there a more general purpose way, or is there some other facility provided by the tool that I just don't know about that
Mm-hmm.
would do this? And you think, oh, well, if I can go look at those, but maybe I won't find them anyway, and then I'm going to come back and have to do it my own special purpose way. So I'll just do it the special purpose, the way I know how. And I can
Yeah.
see why people would fall into that. I
Mm-hmm.
think maybe the way to counter that is you need to make it really easy for people to find out about the best way to do something, the right way to do it in a tool.
Mm-hmm.
And actually, that's an area where I wonder if the large language models can help out, things like ChatGPT. So
Yeah.
if I can digress just a little bit, I have found I've been working in the Linux kernel lately. I'm building a new transport protocol running inside Linux. And I used to spend enormous amounts of time just trying to figure out how Linux worked and get basic answers to questions for things that weren't documented in the kernel.
Mm-hmm.
And what I found is that ChatGPT is astoundingly good at answering those questions. How it does it, I have no idea how it gets this information, but it's able to answer very subtle questions that I was not able to get through Google search. I just ended up having to pour over code to find it.
Yeah.
And so the result is I can get information much faster than I needed to. So if a tool like this were available, say for the testing tools, we could very quickly ask a question, what's the easiest way to sort of invoke this web page? Then if you make it easy enough, then people might be inclined to try that rather than just falling back on previous knowledge they might have from some
Hmm.
previous less powerful toolkit.
Hmm.
I don't think people are necessarily, I don't think they're opposed in principle to moving forward to new tools.
Hmm.
I think we all want to learn how to operate more efficiently.
Yeah.
But but if that's difficult to do, then people will just fall back on the old ways.
Yeah. And actually, you brought a very interesting point because before today, a few hours earlier today, I watched a webinar from the team of Cypress, this tool that I am talking to you about. And they just they are starting to launch as a beta feature something that they call the AI Studio, which is something like it. They so you write your tests with their tool, their open source tool, but then you record the execution of your tests in their cloud service, which is a paid service, and this tool has information to because the tool runs inside the browser together with the application. It has access to the network tab of your browser. It has access to the DOM. It has access to everything that the application is rendering in the browser. And it also has access to your testing code. So they today they showed in this webinar a way to use AI to write tests for you, but not just you don't not even need to prompt the AI to do the thing you want, but you start interacting with the app and it start kind of recording things and at the same time understanding your code base and what is rendering in the front end as well to suggest the change that you have to do. And it was quite impressive seeing what it can do.
If you don't
um,
mind, a slight digress. Let's just try a really simple test. I actually have Chat GPT up on my screen up in front of me. I'm going to
yeah,
try and ask a question about. So the tool is spelled Cypress, like the tree. Is that right?
yeah, exactly.
So I'm just going to say in the Cypress, and this is a web testing tool or just a testing
Web
environment.
testing tool, yeah, yeah,
Web testing tool. What is the best way to invoke a particular web page? Would that be a reasonable question?
yeah,
This is
sure.
it. What is the best way to invoke a particular? I'm just curious if it can answer this question. Invoke a
I'm
particular
pretty
web
sure
page.
it can.
And Bingo says in Cypress, the best way to navigate or invoke a particular web page during a test is by using the sci.visit command.
Exactly what I said before.
Yeah. So, and boy, it goes on. I got like 2 pages of text here about the basic operation of it and tips for better use and what kinds of arguments to pass. So, so I'm wondering, it looks like this information is already readily available.
It is, yeah.
The solution might just be to encourage your students to use a large language model, ChatGPT or whatever their favorite one is, before jumping to a conclusion that they should, use a particular approach they're used to.
Hmm.
Ask the question, because that took literally
Yeah.
15 seconds for me to ask that
Actually,
question.
to be honest with you, in this next the next one that I will have in March, the next class, I'm gonna encourage them because besides the test design masterclass, I have also been teaching about test automation and generative AI, and now I'm starting to mix the both of the things because generative AI is also really good for reviewing your code. Like if you get some testing code and ask for ChatGPT to review it for you, and you can say, act as a Cypress expert and review my code,
I see.
it's gonna. So what I'm gonna encourage my students is, before you send your code for my review, you ask an LLM to review it for yourself. You make the adjustments that you think make sense, because sometimes some of them might not make sense. And after that, you make the adjustments and then you ask for my review. So this is something that I am actually thinking about experimenting. One other thing that I wanted to explore is about, you mentioned in your book about default configurations. Um, and Cypress, for example, has very well thought defaults for its configuration. So when you set up a project for test automation with this tool, the config file is just a small file with a few lines of code, because you don't need to configure mostly anything. It's already pre-configured. You only overwrite the things that you need. And sometimes I see students overwriting something, but exactly by the same value that is the default value. So you are overcomplicating the configuration file, adding something that is already default. I wanted to hear your thoughts on that.
Yeah, there's having default values is great, but it can lead to its own set of problems.
Mm,
So I don't know if you ever programmed in the Ruby language, but
I have.
for example, I taught a web design class here using Ruby on Rails, which provided, at least at the time, a pretty powerful web programming environment where many things just defaulted. And if you gave a file the right name and put it in the right place, just everything would happen and the pages would appear, and you didn't
Yeah.
have to write a lot of configuration files. And that was really useful if you knew what you were doing. But the problem is that the set of defaults, the way it did it was so complicated. There was so much there that to students, it just seemed like magic. It just
Mm.
seemed like I do these things and magic happens and I have no idea what's
That's the
going
feeling
on.
I had when I used to programming Ruby as well.
And and so I don't know. I'm not sure what the alternative is. You'd have to write these enormous configuration files to do everything, which was really tedious and fragile
Yeah.
in its own way. So I've wondered, is there some in between thing somehow where you don't have to write so much stuff, but it doesn't have that flavor of magic? And I think the
I
defaulting is
think
a
there
similar
is.
sort of thing, that all this stuff is set up for you, that does stuff by magic, but you don't know what it is. And so if it's not obvious to you and you
Mm,
don't know what it is,
yeah.
then you're
So
more likely just to repeat stuff that in fact is already done for you.
yeah, in this case specifically, I would say that there is something already in place. Like, talking specifically about Cypress, this is something like, when you are testing with Cypress, you open what is called the Cypress app, where you run the tests. So you see the tests running in a real browser, and you see the command logs in the left, where you see exactly what's going on. I'm visiting the page, I'm getting an element, I'm typing on it, I'm clicking on it, and you can even do time travel after the tests run. You can go to this command log, and you can click on the visit, and you can see how it was the state of the app when you visited the page. You can get an element, and then you can see how it was before and after you typed on it. But in this same Cypress app, you can see the configurations. So there is a tab where you can click and you can see the configuration, and you can see all the defaults, and you can see what is being overwritten by a configuration file, or via a environment variable, or via command line arguments, whatever. So the information, so that you don't have this sense of magic that I had when I used to programming in Ruby on Rails, because the information is transparently there for you. So what my hypothesis is, that people simply, they don't try to understand the tool that they are using, because they just want to, write some tests and see it passing or see it failing if there is a bug, but they don't want to have this deep knowledge on the tool that they are using. And because of that, they fell into this case of like rewriting things that are already there, for instance.
So when I've noticed when thinking about a tool
Hmm.
that you use, there's two ways of thinking about it. One is how much code do I have to write when I'm using this tool?
Yeah.
So tools try and make it so you don't have to write very much code. And oftentimes they only think of it that way. But there's a second way of thinking about it, which is how much do I have to learn? How much knowledge do I
Hmm.
have to have in my mind before I know what to write?
Hmm.
And if you're going to use a tool for a very, very long period of time, then it's worth taking potentially a long time to pick up all that knowledge so that hopefully you can then operate very quickly and only write small amounts of code to get things done.
Yeah.
But particularly if you're doing a small task,
Yeah, for sure.
then the learning time for learning what code to write, that can actually dominate the whole time for your task.
Yeah, for sure. Yeah,
And so in
I
building
agree. Absolutely.
tools, if you want a tool to be really useful, it's important that not only does it reduce the amount of work people have to do once they know what to do,
Yeah.
but also reduces how hard it is for people to figure out
Yeah.
what what to do. And somehow you need to make all of the information that people need to make that obvious to them.
Yeah.
That's something I tell my students in the software design class about coding is that you want code to be obvious.
Hmm.
And by obvious, I mean that if somebody just walks up to your code and reads it, and
Yeah.
maybe they don't read it super carefully, they just took a quick glance through it, and they have to answer a question about it, even
Yeah.
without thinking very hard or working very hard, their first guess to answer all the important questions will be right. that's
Yeah.
that's obvious.
Yeah.
And so it's the same thing about tools. You want it to be obvious what to do, what is the best way to do things.
Yeah.
What I don't know is I don't for tools, I don't know how do you make all of the right things obvious? So
Yeah.
things that are important have to be really, really obvious.
Yeah.
And if you don't make them obvious, then people aren't going to use your tool in a very effective way. And again, they'll
Yeah.
resort to just falling back on anything they happen to have learned in the past that they think will get them to the destination they want.
Yeah. And I absolutely agree with that. And I would say that when I started using this tool, it was end of 2018, beginning of 2019. I was so used to other tools that were very difficult to use. And I saw that it was different. And I decided to do what first? Look at the docs to understand how it works. And when I read the docs, I understood the docs were super good and super well structured. So I realized how different it was, but I spent like 3 nights reading the docs to understand very well how I can benefit from using it. And then I started using it, and I felt so much productive because I knew what I was doing. Um, and I think like this tool specifically, it has it like many of the things are very obvious, which were not obvious in other tools that I used to use. For example, I used to use a tool called Protractor, created by the Angular team, and the method to navigate to a page, it was called browser.get, and you pass the web page URL. It's not obvious. Like get for visiting a page in Cypress is sci.visit. In Cypress, to make a request is sci.request. In Cypress, to intercept a request is sci.intercept. So they thought very well about the API of the tools. And the documentation is really good. And if you are using a typed language, for example, as TypeScript, it has autocomplete. So it's very easy to understand what it does, what arguments it receives, and that kind of thing. But I want to change subjects a little bit to talk about something that I see as well when I'm reviewing the code of my students. I see sometimes hard coded values for things that should be configuration, for instance. So when you're writing tests for a web application, you want to write the same test, and you want to be able to run the same test on against your local environment, but also against a staging environment and maybe even your production environment, where you have different URLs for the front end, different URLs for the API. And most of my students in the first round, they have these values hard coded, which means that if I want to run the same test against a different environment, I have to I have to change the code. What are your thoughts on that?
Well, it's a uh, kind of a natural rookie mistake to make. I I would have students in my software design class who set things up. They were they were trying to write a distributed application that would have servers running on many different machines.
Hmm.
But for their testing, for their development environment, they did all their work on a laptop, and they would set up several applications running on the same laptop talking to each other.
Yeah.
They would end up hardwiring that fact into their code in a way such that it would be impossible to take that code and ever run it on separate machines, because they just built into it the fact that everything was actually on the same machine.
Yeah.
Uh, it's I'm not sure what to say about that, except it's just a really common kind of rookie mistake if you're not thinking ahead a little bit, that you hardwire in all these things that get in your
Yeah.
way.
And it's kind
How
of
to think?
funny
Maybe
because
maybe
please go
it's that
ahead.
I think people naturally tend to specialize, to
Hmm.
make things that are special purpose and do one thing as opposed to generalizing.
Yeah.
And over time, I've realized that I think the single most important thing to good software design is to generalize, to always generalize, even in situations where you think you're only going to use something in a very specific way. Nonetheless, try and at least somewhat generalize that in the API.
Hmm.
And that tends to result in cleaner and simpler APIs, and then it gives you more flexibility later on when you need it.
Yeah.
So I think the lesson to teach is to try and teach people to try and avoid specialization, or delay
Hmm.
it as long as possible.
Yeah.
Sooner or later, every application does something that's very special purpose. In the
Yeah.
end, applications do things that are pretty specialized,
Yeah.
but you'd like to push that specialization out to the very edge of the application, where everything in between and underneath that is fairly general purpose.
Yeah.
And
Yeah.
and that relates to a similar thing I was going to say about tools, which is if you want a tool to be easy to use, I think it has to be based on a relatively small number of very powerful and general purpose concepts.
Yeah.
A few key ideas that, if I understand these ideas, then they allow me to do so many things in the tool. And if I have some new problem I'm trying to solve, no worries. I can just take one of these few ideas and see instantly how it will solve this problem.
Yeah.
Whereas if the tool is a zillion special case little things, then it's really hard to learn something new. I found this I've done some development work in the Gatsby environment recently. I changed over one of my courses to use Gatsby as
Hmm.
the web development environment. And Gatsby has stuff to do everything, but everything is totally special purpose. That I'm unable to predict from anything I've done in the past what I have to do to solve the next problem. I,
Yeah.
I have to, I have to, Google around like crazy and try and find somebody who's done it, but there's nothing. Everything seems to be special purpose.
Hmm.
So again, have this idea of general purpose with a small number of concepts that
Hmm.
you reuse over and over again. I think that's the way you get powerful systems.
Yeah. For this example of the hard coded URLs, for instance, they do it all the time, but then as soon as I show them another way of doing, they pick it up and they understand, and then they evolve. So what I would do, like when I am reviewing their code, I do a few things. So when providing them feedback to improve the design of their code, I try to tell them what is the problem with the design. For example, like a hard coded API URL. Why is it bad? Why does it hurt the design of the code? And then I mentioned to them, well, in that specific case, it would hurt the design because you want to run the same test against different environments. And this way, if I want to run the test that I'm running on localhost and I want to run it on production, I have to change the code. And then I suggest how I would design it better. And then I tell them I would define, friends, for example, this API URL in the configuration file, which I could when I'm running the tests, or just run the tests and pick the environment variable from the configuration file, and it would run with the default. But if I want to run it with against a different environment, I would pass an argument when running it in the command line that I overwrite this environment variable, and then it can run against staging environment, production environment. And when they see it, then they realize how it can be improved. Do you think showing how it hurts the design and then showing a solution is a good way of making people understand how to make a better design of any kind of code?
Absolutely. That's the best way to teach people, I think. It's the style I use in the software design class that I teach here at Stanford. And as I tell people, this goes all the way back to my recollection of learning how to write English in my high school English class.
Hmm.
You know, the way we do things is we'd get a writing assignment and we turn it in and it would be bad. The teacher would mark it up with red ink and pass it back to us. And then we would have to rewrite.
Yeah,
I think that's the way you learn, is that I really learning is, I think, is all about making mistakes and learning from the mistakes.
yeah. And you
Nobody
mentioned
ever
that in
gets
your book
anything
a
right
lot.
the first time. Yeah. And so I think the way to teach people is to set them up in an environment where they have to make decisions themselves. They have
Hmm.
to make some guesses. They will guess wrong. And then you can explain to them why their guess is wrong, what's the principle behind that,
Yeah,
how do they apply that principle in order to do better. And then that's how students learn. And then after a while they can start doing that themselves and applying the principles themselves, and they
yeah,
learn what principle to apply in what situation.
yeah.
And so that's then they become really, really good.
Yeah. There's another topic I want to mention with you here, which is something you mentioned in your book, making the most used use case simpler to use. So in the testing topic here, so let's say I want to abstract away. So I want to test an application where the precondition for testing this application is that I am authenticated. So there is a login page. And most of the tests will need the user to be authenticated. So I want to abstract away the logic for logging in so I don't need to repeat the code all over.
Mhm.
Uh, but most of the times, I want to log in exactly with the same user. And a few other times, I want to test with a different user, right? So what I teach my students is, and when they have to do it themselves, they will create a login function that I can pass the user and the password, and then it will fill the form and click the button and redirect to the logged in page and see that they are logged in. uh, so what I teach them is to use default values for the most used case. Like, so if you want to log in with the default user, which you use in 99% of the tests, you define the parameters of your function with default values. So you don't need to say sci login passing user John with the password 123 ABC. You just say sci.login, it will pick it up from the defaults. And if you want to log in with a different user, then you pass different values from the defaults. Do you think this is a good approach?
Yep, that totally makes sense. What you've done there is you've handled the common case with a default.
Yeah,
Yeah.
exactly. And there's something else that I see a lot, which I'm not going to talk about a lot because I want to hear your thoughts about. What do you think about functions with too much parameters?
Well, um, it's a red flag to me.
Hmm.
Sometimes functions have to have a lot of parameters,
Yeah.
but the fewer the better. Now, I will say, if you're writing infrastructure stuff, it's particularly then I'd be particularly concerned about large numbers of parameters.
Hmm.
Sometimes as you get closer to the top and more to the user interface, in fact, things just are parameterized. There are a zillion options you can use for the interface. And so what do you do about that? I think probably the best way again is to have a defaulting mechanism. Hopefully you have a language that allows you to do keyword parameters like Python, for example.
Yeah.
And then you can default almost all of them. So there's a huge list of parameters I could specify. In
Hmm.
practice, I don't very often need very many of them. And so then
Yeah.
I just in practice specify the individual ones I need in this case.
Yeah.
So then you have the full flexibility for those rare cases where you really do want to specify a lot of things precisely. But in the default case, where you don't need to specify most of them precisely, where defaults will work, then things are very simple.
Yeah.
But in general, again, if you can just build a system that does not have to have large parameter lists, that's better than one that does.
Yeah. My
Can't
golden
always avoid it.
rule, my golden rule is if there are more than two parameters, create an object that has different parameter that has different properties. Uh, Add defaults for the parameters that are not that are not needed in most of the cases to be different than the defaults, because then you don't need to be concerned about the order of the parameters that you pass. So for login, for
Right.
example, logging into the application, you pass user and password. It's okay to have two parameters. But if there were a third, I would prefer to have an object with their keys and values, because then I don't need to care about the order of the parameters, because I can, and I'm talking objects because I am more into JavaScript and TypeScript, which would be a dictionary in Python or hash in Ruby. But I think you understand what I mean. So this is what and this is something very common as well. The students, they pass more parameters, but then you have to remember the order for the parameters, and then if the implementation change, you might have to change all around where you are using that function. But in the other hand, if you have just one parameter, which is an object which has its keys and values, and it has defaults for the most used use cases, then you don't need to care about it.
Yeah, approach like that makes sense to me. It's hard for me to tell whether two is the right number for a cutoff or whether more
Hmm.
of a kind of qualitative recommendation would make sense. But having really long parameter lists, one problem is that when you look at the call, you can't remember what all those parameters mean. And
Yeah,
it's particularly bad if some of them are things like Boolean parameters, where you just have no idea which true and which false
exactly. Yeah,
means what sort of thing to it. If you have now, if you can use keyword parameters where you say name equals value, that makes it better.
yeah, for sure.
But then the other thing about long parameter lists compared to the object approach is you end up writing a lot of things out in parameter lists just because you have to, because the parameters are positional. I need this parameter way out here, so I have to specify all of the ones up to that parameter. And those
Mm,
aren't really relevant to my test case. And so you're forcing yourself and all of the readers of your code to load a lot of information into their mind that really is not relevant to the current situation.
true.
Whereas if you take the object approach in JavaScript, for example, or the dictionary approach in Python,
Yeah,
again, you can focus on what's important and get the things that are not important out of the way. And that's another fundamental rule in order to making code really easy to understand is you want to focus on what's important and try and eliminate things. Don't require people to have to be aware of stuff that's not really important. That just
yeah,
distracts them and makes mistakes more likely.
yeah. There are just three topics more I wanted to explore with you. One of them is, what are your thoughts about premature abstractions? Premature abstractions.
Well, tell me what you mean by a premature abstraction. But I mean, from the name, I would assume it must be bad.
Yeah, yeah. I mean, like sometimes you are using. I have this sense that people, they don't want to duplicate code, right? And because they don't want to duplicate code, if they have duplicated the thing twice, they already create an abstraction. And in application code, it might be okay to do that, or it might not. But in testing code, I do value more the readability of the test, even if it has some duplications, than some abstractions, because I want to read one file with the test code, and I want to understand what is this testing and how it's testing. And if I abstract things away, I have to look at many files to understand what is going on. So this is what I mean by
Yeah, yeah. Uh, that's interesting because I think I tend to have more duplication of code in my test files. Also, I cut and
mhm,
paste more often than putting things into methods. And one of the reasons for that is that when you're reading the test, you really need to know all that information. You want to know exactly what's going on in the test.
yeah,
So I think a good sign that you have created an abstraction that's not helping is if when I'm reading the code of the test, I have to go and read the code of the method that it calls.
yeah,
I have to read that, then putting that in a separate method really hasn't helped me that much. I
yeah,
guess I guess the one way it would help is that if it changes, rather than having to change 20 different tests, I only have to change one
sure,
method.
yeah, yeah,
But but you have to weigh that off against it's now actually you've made it harder for people to read the test code, not easier.
yeah,
It is
yeah,
the abstraction because abstraction by its nature it hides things.
exactly.
And And that's often good. That's why typically we want to do it. We want to hide things that are not important.
Yeah.
But if that information really is important, if I need to know that when I'm writing the test, then hiding it hasn't helped. It's made things worse, not better.
Yeah, yeah. One thing that I think it's very important, for example, that should not be abstracted away is the assertions of your test. I want to read the code and understand what it is asserting about. Like, these are the preconditions, these are the actions, and this is what should happen. And if I have to go to another file to understand, because it's just a assert, it works. Like, what does it mean? I have to look at the function that implements assert that it works to understand what does it
Yes.
mean. Yeah.
Yeah. Although so I would qualify that just a little bit. I mean, I mostly agree with that.
Hmm.
But in my test suites, I also have some standard things, validations that are built into the test infrastructure
Hmm.
itself. For example, to test to make sure that all memory that was allocated was freed during the
Hmm.
test. So there are no assertions in individual tests about that. Instead, at the end of every test, a whole bunch of basic sanity checks are run, and those will generate test errors. And the advantage of that is that then they are automatically present at every single test.
Yeah.
So I don't have to worry about testing for memory freeing errors in a particular test. I just know my infrastructure will do it. So that's
Yeah.
an example where you don't see the assertions. But for the most part, for all of the more specific things to this test as opposed to general things, yeah,
Hmm.
I agree. It's better just to have that assertion in front of you where you can see exactly what it is.
Yeah. The other topic I wanted to hear from you is what about inconsistencies inside test code or any other kind of code? And when I say inconsistencies, let's say for example in JavaScript land where you can have semicolon at the end of an expression, or you can't, and it doesn't matter. It works both ways. Or you can use single quotes or double quotes, and it works. But but you can have the same in the same code, strings with single quotes and other strings with double quotes, expressions with semicolons at the end and expressions without, which I think it makes the code very messy and confusing. Why is this way and why is that other way, if it should actually be the same thing?
I do too. I think you're better off being consistent, unless there's a reason to be inconsistent. But if
Hmm.
there's not a good reason, you might as well do things the same way with the same patterns. Have your tests, for example, have tests with a similar structure, always my setup, then my tests, and then my assertions.
Hmm.
And if you do that, it just makes it easier for people to read because they have certain expectations that are instantly validated. And I think it saves time.
Yeah.
There's I sometimes wonder why languages even bother to provide multiple ways of doing things. Would they be better off if they just provided one way? Sometimes
Ruby
a
is,
different way of
is one that
working.
you can do the same thing with many different ways.
So just because you can, I would say, doesn't necessarily mean you should.
Yeah, for sure. There's the final topic I wanted to hear from you, which I loved when I read in your book, is classicities. Is it correct the way I pronounced it?
I
Classicities?
think classitis. It's like
Classitis.
a
Yeah.
disease, bursitis or whatever. It's like,
Yeah, classitis, because this is something I see a lot in testing code as well, especially when we are talking about end-to-end tests, these tests that are like from the user perspective. So instead of writing things in line in the test code, people tend to create a class where they have all the CSS selectors for the elements that they will interact with, and then methods for the things, and then you have to instantiate a new object to use inside of your test and that kind of thing. And they create lots and lots of classes that call one another, and only the last one do the thing that it should do. And in the end it could be it doesn't need to be that much abstract.
yeah, I would ask, did this abstraction actually make it easier to read the
Hmm.
tests or to write new tests or not? I think, I think maybe what happens, it used to be people didn't write enough methods. They'd write really, really long methods. And so there was this movement that started maybe 20 or 30 years ago to get people to break things up more. And that's just gotten pushed to the extreme. Uh, with things like the one responsibility principle, the method should only do
Yeah.
one thing. And it's so easy to abuse that and take it too far that I think maybe we've gone to the other extreme and now we're erring that people tend to over decompose.
Hmm.
So the question to ask yourself, I think, is what makes the code easiest to read? And
Hmm.
is putting these things in separate classes making it easier to read? Sometimes it does. It can be really helpful. If and the way it's helpful is if I don't really need to know what's going on in that class. All I need to know is some high level stuff. But if I need to know the details, again, then putting it in a separate class has not helped.
Yeah. John, it's been such a great time chatting with you. I want to respect your time, and so I want to thank you for being here. Is there anything that I haven't asked you that you would like to share, or any final note for our audience here at the Talking About Testing channel?
Just one note, which I mentioned in the software design book, to have in the back of your mind, whether you're writing tests or code or anything else, and that is the way to have really great designs or have clean structures is you have to decide what's important
Hmm.
and focus on what's really important. Think about what matters. And that's come up several times in our conversation. Like if the details are important, then you want to expose those and make those visible to people.
Hmm.
And what we'd like to do is to make as many things as possible not matter. That's the best thing. If you could take something and decide, actually, people don't need to know about this, I'm going to hide it behind an abstraction.
Hmm.
But you have to recognize if it matters, then you need to expose it. So just think about in your mind what matters, what's important, what's not important, and try and really focus on the stuff that's important.
That's a great one to wrap it up. John, thanks again for being here. I hope you enjoyed it as well. I enjoyed it a lot. And thank you for you that are watching the video as well. If you did like it, hit the like button, hit the subscribe, and I talk to you in the next one. Have a good one, John.
Thanks for inviting me. I enjoyed talking with you.
Thank you.